you through, and there will be, it's kind of a path, flow, and hence it's journey of transistors. So with that, let's, so if we talk about the journey and the evolution, right, it is very similar to how the buildings have evolved. So initially, back in probably early 19th century, we had big joint families, and the spaces were big and the houses were bigger. As we moved in our early 1990s, 1980s, we had a smaller house, independent house. And then it was much optimized. Power consumption was optimized. Then slowly we moved into these 3-story buildings, apartment complex, small apartment complexes, wherein, again there were common facilities, much optimized facilities, optimized power consumption and things like that. And then we moved into apartment complex where that's centralized. You have all the things flowing centralized. And then if you see in this picture, it also shows the vertical garden kind of thing, apartment complexes, which might talk about the carbon emission. So with that, if we keep the analogy in the similar path, right, that's how is our journey going to be. So we'll hold this thought at this point of time. And today's outline would be device evolution, its history, introduction, future devices. So we'll go through FinFETs, nanosheets, CFETs, fork sheets, and so on. I'll briefly talk about Standard Cell Library, the domain that I work, and very brief introduction of what work we are doing in. And then we'll see what is there in future, role of AI, and then we'll close the session. So let's begin. So what is this? So any guess? So this is basically an electron tube, so-called vacuum tube, the first electronic device. So here it has, as you can see, it has a cathode, anode, and it has grids. And in vacuum and with electric field, there is a movement of current. Okay, so, but it had some drawbacks. So it was highly unreliable, very bulky, and expensive. However, even in today's world, actually, it is still used in musical instruments as warmer. So there is a use of it, but we don't no more use it as an electronic device. Okay. So then came in our next friend, who is, had some things which is built-in junction, so which is diode. So here it was PN diode. The first form came into picture. So this had, when you put it in forward biased, there is a flow of current, electrons will move, but it had a rectification, but it really didn't have amplification, oscillation, the other features that a transistor needs. So that was not there in this device. So then slowly it moved into the next phase, wherein our very closest friend, bipolar junction transistor, came into picture. So it's nothing but two PN back-to-back NP diodes that are being placed together, and they are basically doped in such a way. So we have a lightly doped P region and heavily doped N regions here. And there is a flow of, let me get the pointer, just one moment. Okay. There was electrons recombination, and then there was flow of current, which was needed, and it played a pretty much good role. But then this also had some of the drawbacks. So it did give us rectification. It did give us amplification. It did give oscillations also. It actually, in fact, sustained